Hello students, this is Brahmo, Faculty of Reasoning. Today we'll see one of the important topic, that is directions and distances, and it is important for almost all competitive exams. So wherever reasoning portion is there, there will be question from this topic, that much important. Particularly these concepts are very much helpful in some other topics. So it has major applications. Its major application is of seating arrangement. So we use this concept in seating arrangement majorly. So wherever right left concept is there it will be helpful in the seating arrangement, ranking, directions itself. So wherever right left concept is there this topic will be helpful and these concepts will be helpful. So first of all we'll see models in this topic. First model is rotation based problems. Next is clock based problems. Next is compass based problems. Next is shadows based problems. Direction and distance based problems. And this is the important model out of all the models, direction and distance based problems. Generally we'll get question from this model only. Next model is points based problems. Points based problems. And one more is coded directions. Coded directions. So first we'll see all the concepts. Later we'll move on to the problems and we'll see the problems model by model. So by taking one by one models, we'll do examples. First we'll see the concepts. Yeah, what are the basic directions we have? So basic directions are north, south, east and west. North, south, east and west. So these are the four basic directions we have, and there are four more derived directions are there and derived from these four directions only. What are those derived directions? They are northeast, southeast, northwest and southwest. So these are the four basic directions and these are the derived directions or corners. We can also call them as corners. Between north and east it is northeast, south and east southeast, southwest and it is northwest. Next, so angle representation between the among the directions. Angle representation among the directions. If we consider north as 0 degree, if we consider north as 0 degree in the clock direction, so 90 degrees is east, 180 degrees is south, 270 degrees is west, and again 360 degree is north only. Suppose if we consider in anti-clock direction, then it will be 90 degree, west will be 90 degrees, south will be again 180 degrees only, east will be 270 degrees, and west again north is of 360 degree. Again north is 360 degree. So what about northeast, southeast, and northwest and southwest? So northeast is of 45 degrees. Exactly 45? So no. So many will consider northeast as 45 degrees. This is not the right assumption. In ideal case, it is 45 degrees. Okay. In ideal case, 45 degrees. But actually, it is not. Northeast is not a single line. Northeast is not a particular direction. It is a derived direction. Or we can also call it as northeast is the region. Northeast is a region between north and east. It is not a single line. It is the complete region. Complete region between north and east is northeast. Between south and east it is southeast. Between south and west, southwest. Between north and west it is northwest. Yeah, this is the original diagram. See here. So these are the basic directions: north, south, east, and west. So this is the region from north to east. This is northeast. So this is the region between south and east. This is southeast. So this northeast is not single line. This line, it can be anywhere, any place in this region. It can be any place in this region from starting from 0 degree to not 0 degree, more than 0 degree, greater than 0 degree to less than 90 degrees. So northeast, what is the angle of northeast? Northeast can be any angle between 0 degree and 90 degree. Northeast is any angle between 0 degree and 90 degree. Okay. So what is the possible angle of southeast? What is the possible angle of southeast? Considering north as 0, possible angle for southeast is between 90 and 180. Possible angle for southwest is between 180 and 270. Possible angle for west, northwest is between 270 and 360 degree. Between 270 and 360 degree. Considering north as 0 degree, and in the clock direction it is. So one point is clear now. So northeast, southeast, northwest, and southwest. If we are considered as a 45 degrees, means it is a ideal case. In some cases we can consider it as an 45 degrees only in ideal cases. So it can be any angle. Right. Next is right-left concept. Suppose if a person is at origin, tell me the answer. Suppose if a person is at origin and he is facing towards north, his right hand shows which direction? So many of you will say it is east. Not exactly, because I didn't mention the angle. Right. So if a person is facing north, if he turns 45 degrees clockwise, it can be northeast. 90 degree clockwise, east. 180 degrees clockwise, south. 135 clockwise, southeast. 130 clock, southeast. 100 degree clock, southeast only. 190 degree clock, southwest. 270 degree clock, west. 300 degree clock, northwest. And 360 degree clock can be north. So means all the directions are possible, but simply you are telling it is east, sir. No, it is not east. It can be any angle out of all the angles, right? So because I did not mention the angle. Suppose if I tell in this way, if a person is at origin and he is facing north, he turned 90 degree clockwise. So yes, this is exactly east. If he turned 100 degree clockwise, so then it is southeast, right? But sometimes he will tell one time right. He turned one time to his right. So one time right will consider exactly 90 degrees. So one time right exactly 90 degrees. But it is in which direction? Clock or anti-clock? Yes, it is clock direction. So if one time right is 90 degrees, then two times right will be 180 degree clockwise. Three times right will be 270 degree clockwise. So one time right is exactly equal to 90 degrees in clock direction. In the same way, one left is exactly equal to 90 degrees in anti-clock direction. 90 degrees in anti-clock direction. So if one left is 90 degrees anti-clock, then two times left will be 180 degrees anti-clock. Three times left will be 270 degree anti-clockwise. Right. So in maximum cases, mostly in directions topic, we'll consider right as a clockwise, left anti-clockwise. Right means clockwise, left means anti-clockwise. Most of the cases, because always will consider the person he may move in any direction. So we'll consider person started at origin. We'll consider in that way. So he will move away from the origin means it will be applicable. Any person moving away from the origin, this concept is applicable. Right means clockwise, left means anti-clockwise. Tell me, suppose if a person is at origin and is moving towards east, is the right hand shows which direction? Person is at origin and is moving towards east. Right hand shows which direction? South. Left hand shows north. North opposite south. South opposite north. East opposite west. West opposite east. East right side south. East immediate right southeast. East left side north. East immediate left northeast. West right side north. West left side south. South right side west. South immediate right southwest. North immediate left northwest. North right side east. North immediate right northeast. So if it is if you think this is fast, you can slow down in your YouTube. In settings there will be speed increase or speed decrease also, or you can see repeatedly also. Right? If you are clear with this concept, right left concept, then many problems will be easy and we can do them faster. Right. So the same concept already we covered. Directions with the right left concept. So person is at origin facing north, right hand shows east, left hand shows west. Person is at origin and is facing east, right hand shows south, left hand shows north. Person is at origin and is facing south, right hand shows west, left hand shows east. In that way. Next concept. See here. So generally till now we have considered if these are the directions. Always we are considering this as north, south, east and west. East and west. Sir, why don't we take in this way? Suppose if it is east. Sir, can it be east? Yeah, it can be east. It can be east. So, sir, how it can be east? It should be north. No, it can be east also. Because already we discussed in the before slide. What is the east opposite direction? East opposite is west. East right side, south. East left side, north. So between north and east it is northeast. Between south and west, southwest. Between south and east, southeast. And between north and west, it will be northwest. And now tell me, is it a right diagram or not? Yes, it is also the same. East opposite is west, north opposite south. Between north, south and east, between north and east, northwest and south and west. So the my intention here is anywhere if it is required, we can rotate the directions. Okay, directions can be rotated. Directions can be rotated, but without disturbing the original directions. Without disturbing the original directions, they can be rotated. Next concept: directions comparison with clocks. Directions comparison with clocks. Right. So these are the directions, and it is the clock we know already. Generally, we'll consider north towards 12 o'clock, or 12 o'clock towards north. We'll consider 12 o'clock towards north. If 12 o'clock is towards north, now tell me exactly at 12 o'clock our hand shows in which direction? Yes, north only. Minute hand is also showing north only. Suppose at 3 o'clock. At 3 o'clock our hand shows number 3 means that is towards east, but minute hand shows towards north. Exactly at 6 o'clock. 6 o'clock our hand shows number 6 means that is south, but minute hand shows north only. And exactly at 9 o'clock, our hand shows west, but minute hand shows north. And not only for these 4 timings, we can also tell the directions. We can also tell the direction of minute hand and our hand at any particular time. At any particular time. So we'll see in compass based problems. Compass based problems. We'll see there's some questions in that model. Next one. Next concept. Shadows. Next concept is shadows. So considering this border, for this board, this is north, this is south, this is east, and it is west. So in the morning, sun is on the east side. Sun is on the east. If object is here, its shadow will be on the west direction. In the evening, at sunset, if it is the object, its shadow will be on the east direction. So in the morning, sun is on the east, object's shadow is on the west. In the evening, sun is on the west, but object shadow is on the east direction. So what is the object? Object or person? So person also can be an object. What is the facing of that person's relative? So means whatever may be the person's facing direction, but his or her shadow will be on the west direction. If the sun is on the east direction, right? And this shadow position is independent of facing direction. So it is on the west direction only. So now let us see the shadow positions in the morning case. Shadow positions in the morning case. Now see. In the morning, person is at origin. Sun is on the east direction. And the shadow will be on the west direction. Just now we told that point, and it is independent of facing direction. In the morning, sun is on the east direction, shadow is on the west direction, person is in the middle at origin, considering that person at origin. So if he faces towards north, so sun is on his right side or left side? So for a person facing north, this will be the right side and it is the left side. Right side and left side. Sun is on his right, but here we mentioned shadow position. But shadow is on his left side. So this is the point. If person is facing north, shadow is on his left. Shadow is on the left. Suppose if person is facing south, for a person facing south, this is the right side and it is the left side. So sun is on the left side, but here we are seeing the shadow position. That's why shadow is on the right side. If person faces east, if the person is facing east, means he is facing the sun. So automatically shadow will be on the back side. Person is facing east means his shadow is on the back side. If person is facing west, so person is facing west means the sun is on the back side, but his shadow is in front of him. Person is facing west, his shadow is in front of him. And the same concept will be reversed in the evening case. Now let's see that evening case also. So in the evening, sun, what is the position of sun? Yes, west. So person is at origin. In the evening, sun is on the west direction. Shadow is on the east direction. Suppose the person faces north, so we are seeing the shadow positions. Person faces north, shadow is on his right. Person faces south, shadow is on his left. Person faces east, his shadow is in front of him only. Person faces west, his shadow is on the back of him. Okay, now shadows concept is clear now. If you are clear with these shadow positions, many questions can be solved with without using pen paper also. Next, directions comparison with compass. Directions comparison with compass. So you know compass? Yes. In a compass, there is a pointer which is of red colored. This is the pointer, red colored, and that red colored pointer will always shows north only. This north is not in the dial, not in the dial, and this north is always that north is always original north according to the earth north south position. It will always shows towards north only. Right? And comparing with these directions and this pointer location, we can frame some questions. So we'll see the questions in that model. So now let us move on to some example problems and model by model, that too model by model. So first try to understand the concept with these problems, and all the concept till now we have seen. I will apply in these problem solving. So you have to learn problem solving techniques using those concepts. So we'll see first example. One fine morning, Kushi is practicing yoga facing the sun. Kushi is practicing yoga facing the sun. First, she turns 45 degrees clockwise, followed by 135 degrees anti-clockwise. So first we'll do the question in the regular method. Later we'll see the same question in the shortcut method. So this is the regular procedure. Yes, Kushi is in this location. First sheet and one fine morning. Okay, it is the morning, and she is practicing yoga facing the sun. Means indirectly he is telling the initial facing direction. Initial facing direction. What is in the morning she is facing the sun means she is facing which direction? Yes, she is facing east. So Kushi is in this location and she is facing east. Kushi is in this location and she is facing east. So from there she started rotation. So first she turns 45 degrees clockwise. So let us take 4 more derivative directions. Yeah, this is north, south, east and west. This is southeast. Sorry. This is southeast, northeast, northwest and southwest. Yeah, initially she is facing towards north. From there, first she turned 45 degrees clockwise. So if she turns 45 degrees clockwise, what is facing direction? What is her facing direction? Southeast. So followed by means after that 45 degrees, 135 degrees anti-clockwise. 135 degrees anti-clockwise. From here, 135 nothing but 95, 90 plus 45. So from here to here it is 90 degrees plus 45 more. So now she is facing north direction. And then she turns 90 degrees to her right. Right nothing but clockwise. Right means clockwise. In clockwise direction it is 90 degrees again. So from here 90 degrees in the clock direction. And followed by means after that one time to her right. Is one time to her right. So one time nothing but right means clockwise. Okay, one time 90 degrees. 90 degrees in the clock direction again. So from east to 90 degrees again, clockwise direction. And finally she is facing which direction? That is south. So once again we'll see. One fine morning, Kushi is practicing yoga facing the sun. Means initially she is facing east. First she turns 45 degrees clockwise, followed by 135 degrees anti-clockwise. Then she turns 90 degrees to her right, followed by one time to her right. Finally she is facing south. So answer facing now. Now in directions topic, now always represent the final position. Now always represent the final position. Now at this point of time, nothing but at this point of time she is facing this south. So final answer is south. So this is the regular method and the traditional method. Now let's see the shortcut method. Here we don't need to draw the diagram, and directly we can go with the angles only. So initially she is facing east. So from there he turned 45 degrees clockwise. Then she turns 135 degrees anti-clockwise. So then she turns 90 degrees to her right. 90 degrees right, nothing but clockwise. And followed by one time to her right. One time right, nothing but 90 degrees in the clock direction. So 90 degrees in the clock direction and stops. That's all. And stops. So here do one thing here. Add all clockwise and add all anti-clockwise. Add all clockwise and add all anti-clockwise. And do the subtraction. Clockwise and anti-clockwise, take their difference. And which direction we have to consider? Bigger element direction. Bigger angle direction. If clock is bigger, we'll consider the resultant angle will be clockwise only. If anti-clock is bigger, we'll consider the resultant angle is anti-clockwise. Even after addition only, we have to subtract. So in that case, directly we can cancel some angles here. So 45 degrees clockwise and 90 degrees clockwise. So what is the sum of these two? 135 degrees clockwise. Directly we can cancel with these 135 degrees anti-clockwise. So these two resultant will be 135 degrees clockwise, and we can cancel with that 135 degrees anti-clockwise. So what is the final resultant angle? 90 degrees clockwise. 90 degrees clockwise. So our answer will be 90 degree clockwise. From where it is 90 degrees? From east. Directly see that one. From east. This is east. From east to 90 degree clockwise will be south. So answer is south. So which is better? Yes, second. In which model it is? For rotation type questions, rotation based problems, so this is the best method. This is the best method. Why this is the best method? So there are some advantages. Number one advantage with this method is, so first advantage is, in this case, angles can be multiples of 45 or may not be multiples of 45. Our procedure is same. But in this method, if the angles are not multiples of 45, suppose person is at origin, and he or she is facing north. He turned 45 degrees, then it is okay. He turned 90 degrees, then it is okay. Suppose if he has given 100 degrees to his or her right, where we have to mention that point, it is somewhere between 45 degrees and it is somewhere between 90 and 135. Somewhere we have to mention here. And the next angle will be the continuation from this position. So it will be somewhat difficult. So this is the best method for rotation type questions. That is one advantage. And second advantage is, in this method, as long as the initial point is mentioned, we'll start from that point only. Sometimes you will not give initial position. After all the rotations, you may give final position. But from where we have to start the solution? Don't know. So we have to solve it completely in a reverse manner. We have to solve that question. But here he may give initial direction and asking for the final direction, or he may give final direction and asking for the initial direction. This concept is in this process is clear. So first we need to find the resultant angle of all the angles. Resultant angle, this 90 degrees we can call here as resultant angle. 90-degree clockwise is the resultant of all the angles. Instead of turning 45 degrees on that 90 degree, 90 degree, directly we can turn this angle and it is equivalent to all the angles. Okay, clear. Practice some more questions. This method. Yeah, second example is also based on the same rotation based on the same rotation. Yeah, now see here 100 degrees is there, 60 degrees is there, 30 degrees is there. How to represent this 100 degree, 60 degree and 30 degree in our directions? Can you represent? No. So this method is somewhat better only when the angles are multiples of 45. So 45 0 times, 45 1 time, 45 2 times, 45 3 times, 45 4 times, 45 5 times. So then it is better. Other than 45 multiples, our method, second method is, shortcut method is the best. So we'll try this question in shortcut method only. See here first. A boy is rotating, standing in a place facing north. So he has mentioned initial the direction as north. So from north he is starting rotation. First he turned 100 degrees clockwise. 100 degrees clockwise. Followed by, means after that, one time to his left. One time left is nothing but 90 degrees left means anti-clockwise. Means anti-clockwise. Then he turned 60 degrees anti-clockwise. Then he turned 60 degrees in anti-clockwise direction. Followed by means after that two times to his right. Two times to his right. Two times right. One right is equivalent to 90 degrees clockwise. Two times right is equivalent to 180 degrees in the clock direction. Finally, he turns 30 degrees to his right. So 30 degrees is also in the right direction only, means clockwise direction, and stopped. So right. Now take the resultant. Add all clockwise 100 degree plus 180 degree, 100 degree plus 180 degree plus 30 degree. 100 plus 180, 280 plus 30, 310 degrees. 310 degrees clockwise minus 90 plus 60, 150 degrees. 150 degrees anti-clockwise. So what is the resultant? 310 degree and 150 degree, and the resultant is 160 degree. So which direction we have to consider now? What is the bigger angle direction? 310 is bigger or 150 is bigger? 310. What is its direction? Clockwise. So we'll consider the resultant direction as clockwise only. Now 160 degree clockwise. So our answer will be 160 degrees. 160 degrees clockwise from north is the answer. 160 degrees clockwise from north. 90 degree clockwise from north is yes, east. 180 degree clockwise from north is south. But this 160 is between 90 and 180. That's why between north and between south and east it will be southeast. So from north, this is 90 and it is 180. But if this is 160 is between this east and this south, so our answer is southeast. Our answer is no, southeast. And it is not mandatory, compulsory, it should be 135. In ideal case, it can be 135. Okay, but our concept is between south and east, anywhere it can be southeast. Anywhere it will be southeast. Yeah, now practice some more questions based on rotation based problems. Next, we'll see next example. Example 3, also based on rotation. So why third example? Third example, the reason is see the question first. In which direction he started initially? In which direction he started initially means he has given the final direction. Final direction is given, and we need to find the initial direction. So already we mentioned that point in our method, in our shortcut method. He may give initial and asking for final, or he may give final and asking for initial. Our procedure will be the same. Our procedure will be the same. So first we need to find the resultant angle. So somewhere he started rotation. We don't know that point. So somewhere he started rotation. One evening while doing exercise, Vishwa turns 45 degrees clockwise. So first of all 40 degrees clockwise, followed by 130 degrees anti-clockwise, followed by 130 degrees anti-clockwise. Then he turns 135 degrees to his left. 135 degrees to his left. Left means anti-clockwise. So followed by one time to his right. One time to his right. One time right is 90 degrees. Sorry, one time means 90 degrees. Right means clockwise. So totally it is 90 degrees in the clock direction. So finally he turns 50 degrees clockwise, 50 degrees also clockwise, and faces the sun. So finally he is facing the sun. Means indirectly he is telling the sun faces the sun means is facing some north or east, sorry, east or west. So is it a morning or evening? Evening. Evening sun is on the east direction or west direction? West direction. Person is facing the sun means a person is facing the west direction. So final facing direction is west. Final facing direction is west. So here we'll find the resultant angle first. Add all clockwise. 40 degree, 90 degree plus 50 degree. 40 plus 90 is 130 plus 50 is 180 degrees clockwise. 180 degree clockwise. Next, add all anti-clockwise. Yeah, these are the two anti-clockwise directions. The sum is 265. 265 degrees anti-clockwise. What is the difference? 265 and 180 degrees. What is the difference? Yes, 85 degrees is the difference. 85 degrees. Here question is 85 degrees, but which angle? Which direction? Anti-clockwise. Anti-clockwise. This is the resultant angle. So here our question will be from where 85 degrees from where 85 degrees anti-clock from where 85 degrees anti-clock will be west. So from where 85 degrees anti-clock will be west? See the directions. So this is west. From where 85 degrees anti-clock will be west. So we need to start from which point, which direction or which position. So we can convert this into in our regular previous questions. See once. If we change initial and final positions, clock will be anti-clock, anti-clock will be clock. Okay. Suppose this is the final position. If we consider that as initial, and initial will be final, 85 degrees will be the same, 85 degrees only. So then anti-clock will be clockwise. So now see our question. What is the actual question? From where 85 degrees is anti-clockwise? From where 85 degrees anti-clock is west? The same question we can also consider it as from west 85 degrees clockwise will be from west 85 degrees clockwise will be which direction? So this is west. From here 85 degrees clockwise. Suppose if it is 90 degrees it will be north, but 85 is not reaching 90 degrees, not reaching 90 means it is between north and west. So answer will be northwest. Answer will be northwest. Okay. So remember this point. If we change initial and final positions, clock and anti-clock will be reversed. Clock and anti-clock will be reversed simply. Yeah, next example. Clock based problems. Clock based problems. Yeah, see the question. Time in a clock is 9 o'clock. If the minute hand shows west, then hour hand shows which direction? This is 12, 6, 3, and 9. Time in a clock is 9 o'clock. At 9 o'clock, our hand shows which direction? At 9 o'clock, our hand shows, sorry, not direction, sorry. Our hand is on which position? Which number? 9. Minute hand is on which number? Exactly on number 12. So at 9 o'clock, our hand is on number 9 and minute hand is number 12. At this point of time, if minute hand shows west, suppose if this minute hand is pointing towards west. So we learned one point. Directions can be rotated. Whenever it is required or wherever it is required, you can rotate the directions. Now tell me, west opposite is east. West left side is south. West right side is north. Actually, we don't need these two positions. So simply this point is enough. Yes, exactly at 9 o'clock. If minute hand is pointing towards west, our hand will point towards south. And this is our question. If the minute hand points towards west, our hand shows which direction? Our hand shows which direction? South. So practice that right-left concept clearly. North opposite, south opposite, north right side, east opposite, east left side, right left, west right side, west left side. Practice those points. Next example. Clock based problems, second example. Clock based problems, second example. So see here. Jyoti observes the reflection of a clock in a mirror. So Jyoti is unable to see the clock directly, but she is able to see the reflection of the clock in a mirror. Time observed by her. So what is the time observed by her? 4:30. So is it the actual time shown by the clock? No, because she is observing in a mirror. So in the mirror, if it is 4:30, what is the actual time? What is the actual time? Yes, we have a shortcut to find that one. We'll see that shortcut clearly in clocks topic, but here we'll use that shortcut. To find mirror times, simply subtract given time from 12 hours. 12 hours or 11 hours and 60 minutes, because both are same. 11 hours and 60 minutes. So I'm subtracting the given time 4:30 from 11:60. Subtract 11 minus 4 is 7. 60 minus 30 is 30. That is 7:30. So this is the actual time shown by the clock. So here the question is, in the actual clock means at 7:30, if the hour hand shows north, then minute hand shows which direction? So see, in this actual clock, this is 12, 3, 6, and 9. This is 8, and it is 7. At 7:30, our hand is on number 7? No, it is not on number 7. It is somewhere. Not somewhere exactly between 7 and 8. At 7:30, our hand is exactly between 7 and 8. And minute hand is on which number? Number 6. Because it is 30 minutes up. Exactly on number 6. Right. In this at this point of time, 7:30, our hand shows north. If the our hand shows north, this is our hand side. Our hand is showing north. Now see, north opposite south. North right side east. North left side west. And this pointer or this number 6 is between north and west. That way, that's why it is northwest. So in which direction the minute hand is showing? Minute hand shows northwest. So answer is northwest. Okay. So for this purpose only, I am repeatedly telling. Try to learn that concept clearly. Right, left concept. Next, let's see one more example. Now it is compass based problems. Compass based problems. Already we mentioned that pointer. There is a pointer in that compass, and the pointer always shows towards north only. Towards the original north, not in the dial of that compass. That is original north. Read the question first. The compass was damaged and its turned needle turned in such a manner that in such a way that the pointer which was showing north, actually it should show north, is now showing west. So by mistake it is showing towards west. Actually it should show towards north only, but it is showing west. And using this compass, Chinni went towards east. So we don't know that the pointer needle turned. We don't know the compass was damaged. Using this compass, that Chinni is going towards east. Is he moving in a required direction? No, he's not moving in a required direction. By thinking it is east, he is moving. By thinking it is east, he is moving. But the question is, then in which direction is he going actually? He is thinking that it is east, but actually what is the direction? We should tell. Right? Okay. Now let's see. This is the compass. There is actually only one pointer that is always showing north, but here I am taking 4 pointers for our comfort. So originally this is north, originally this is south, this is east, and this is west. Now tell me, in a original compass, this pointer is always showing north only. So can I call it as a north pointer? Yes, this will be the north pointer. And in original compass, this pointer is always showing towards south. Can I call it as south pointer? Yes, it will be the south pointer. The pointer always showing east is east pointer. The pointer always showing west is west pointer. So outside are the directions. Inside are not the directions. Inside are the pointer names. This pointer name is north pointer, east pointer, south pointer, and west pointer. Because they are showing those directions. According to the directions, we name those pointers. This is the original compass. Now see, after their damage, now it is damaged, then it will be. This is the damaged compass. Again, I am taking the 4 pointer locations. So simply tell me one point here. Suppose one person is moving somewhere using a compass, original compass. Suppose suddenly it fell down. In that situation, suddenly all the directions will change, or in that inside the compass, location of pointers will change. Yeah, only pointer locations will change, not the original directions. Original directions are always the same. So originally it will be north only, south only, east only, and west only. So for the original compass, and even after its damage also, the original directions are same: north, south, east, and west. Here also north, south, east and west. But what is the change? What is the difference for the damaged compass? So pointer locations are disturbed. Pointer locations are disturbed. Actually, this is the pointer setter. It is a repeated pointer setter, but because of its damage, set will be disturbed. Set is disturbed. How it is? It was disturbed. He is mentioned that point in the question only. The pointer which was showing north. So till now, what is the pointer that is showing north? That is north pointer. Till now, what is the pointer that is showing north? North pointer. And that north pointer is now showing west. So the north pointer is turned, disturbed in such a way that now it is showing west. That north pointer is now showing west. So based on this north pointer, we can name the remaining pointer locations. Pointers. North point opposite is south pointer. North pointer right side is east pointer, and north pointer left side is west pointer, or opposite to east is west pointer. So this is the damaged compass, and using this compass a man is moving towards east. So that chinni moving towards east, observing, is it that outside east or inside east? No, if you know outside east, what is the purpose of this compass, right? So by observing inside the compass, is moving towards east, but actually is moving which direction? North. So answer is north. This is the original concept of compass. This is the original concept of compass. So the same question can be solved in simple manner also. We'll see that that one also, that procedure also. This is north, south, east, west. Yeah, the pointer which was showing north is now showing west. So that pointer which is showing north is now showing west. Is now showing west. Means that set will be rotated 90 degrees in anti-clockwise direction. This complete set of pointers is rotated 90 degrees in anti-clockwise direction. So means if it is north, north will be rotated here, then automatically west will be here in the new damaged compass. Then south will be here in the damaged compass, and this east will be here in the damaged compass. So then in which direction person is going actually? Sorry, Chinni went towards east. So he went towards east. He went towards east. So in which direction is he moving now? Actually, that is north. Means question C here, small point. If north become west, yes. If north is now showing west, means if north become west, then east will be dash. East will be dash. That is the question. If north is west, east will be north. If north will be west, east will be north. Got it? Yes, this is the alternative method. Yeah, next example. Shadows based problems. Shadows based problems. Example 1. One morning, read and understand the question first. One morning, Likith is running. One morning, Likith is running. He observed his shadow to his left. He observed to his shadow to his left. So, in which direction is he running now? If you remember the previous concepts, directly you can get the answer. But see here, Likith is here. He is running towards in which direction? That is the question. In the morning, sun is in the east direction. His shadow is on the west direction. Sun is on the east direction. His shadow is on the west direction. And he is telling that his shadow, the shadow is on his left. So the shadow, if he is facing west, it is in front of him. If he is facing east, it is back of him. If he is facing south, this is on the right of him. And if he is facing north, this is on the left of him. This is on the left of him. So he has given shadow is on his left, means person is facing which direction? North direction. So that is the answer. Simple. So see here once we'll go to the previous points. Yeah, morning case. Yes, in the morning case, shadow is on his left, means person faces north. Simple. Shadow is on his left, means person is facing north. That's all. He observed that shadow is on his left. Which direction is he running now? Yes, east. Sorry, north. Next example. Second example. One evening, Chinnu and Bannu. One evening, Chinnu and Bannu were standing in a lawn facing each other. They both are standing in a lawn facing each other. Shadow of Bannu fell exactly on the right of Chinnu. Shadow of Bannu fell exactly on the right of Chinnu. So now let us draw the diagram first. Corresponding diagram. In the morning, this is evening. In the evening, sun is on the west direction. Persons are here in the middle, and their shadow is on the east direction. Sun, these are the two persons, and their shadow. Suppose this is person A and it is person B. Now can you tell me whose shadow is this? Yeah, no, we can't say. No, we can't say because both the persons are here, and for both of them, shadow is on the east means west means both their shadow will be on the east direction. We cannot say whose shadow is this. We cannot say whose shadow is this, right? And here we are mentioned one point that two persons are facing each other. The two persons are facing each other. So this person is facing this one, and this person is facing this one. So keeping aside all the concepts and points, just give some answers here. My question. Based on this line, what are the possible directions for this line? Yes, either north or south. What are the possible directions for this line? Yes, either east or west. What are the possible directions for this line? Yes, it is either northeast or southwest. What are the possible directions for this line? Either northwest or southeast. Now tell me what are the possible directions. No, sir, it is not possible direction. It is a confirmed direction, that is northwest. Now the direction southwest. Now it is east. Now it is south. Yeah, based on line and arrow. Based on line and arrow, we can predict the directions, facing directions. Yes. Based on this line and arrow, can you tell me in which direction this person is facing? Yes, he is facing north. Based on line and arrow, can you tell me in which direction this person is facing? Yes, he is facing south. Yeah, now tell me, for a person facing north, this is the right side or left side? Right. And this is left. For a person facing south, this is right and this is left. Yeah, this is the, now the diagram is ready. The diagram is ready. These are the persons, sorry, this is the sun and these are the persons and it is the shadow. This person, both the persons are facing each other. This person is facing north, right side, left side, and this person is facing south, right side, and left side. Yeah, now now read the question. Shadow of Bannu. Whose shadow is this? Both their shadow is in the same direction. So for this example, I am considering the shadow as a Bannu's shadow. Okay, Bannu's shadow is fell exactly on the right side of Chinnu. So can you tell me for which person the shadow is on the right Chinnu? Among these two persons, for which person the shadow is on the right? For this person it is right side, and for this person it is left side. So we know already Chinnu's right side is there shadow. So assign that person name as Chinnu because shadow is on the right side. So this person will be Chinnu. Automatically opposite person will be Bannu. Yes. Now tell me, in which direction Chinnu is facing? Yes, north. In which direction Bannu is facing? South. Chinnu's right hand shows east. Chinnu's left hand west. Chinnu's backside south. Bannu's right hand west. Bannu's left hand east. Bannu's backside north. So and two more questions. Bannu is in which direction of Chinnu? So remember these points in directions topic. The words like of or with respect to or from. Sometimes it can be to also. So in directions topic, this list of words represent the reference. Who is the reference? Generally in directions topic, what is the reference? Reference nothing but origin. Origin is the reference. So with respect to of, from, to, these words represent the reference or origin. So here the question is, Chinnu is in which direction of Bannu? Of Bannu. So if Bannu is the origin, to see Chinnu, in which direction we need to see? That is towards south. The answer is south. Answer is south. Bannu is in which direction of Chinnu? North. Right. So this is the actual procedure and detailed procedure with the concept with the procedure, and that is the solution. And without all this procedure also we can directly tell the answer. So using that shadow positions based on the shadow positions. Now see one evening shadow right of Chinnu. One evening shadow right of Chinnu. Now go to that one. Evening shadow right of Chinnu. Yes, this is the evening case. Shadow right of Chinnu. Shadow is right of Chinnu means Chinnu is facing north. Chinnu is facing north means automatically Bannu will be facing south. Chinnu is facing north means automatically Bannu is facing south. The same. Yeah, is it the same or not? Evening shadow of Bannu. No, not shadow. Evening shadow exactly right side. So don't concentrate on whose shadow it is. So for this question, that is not much important. Sometimes he may give Bannu shadow, sometimes he may give Chinnu shadow, sometimes simply he will give shadow, not without this point. So shadow falls exactly on the right side of Chinnu. So don't concentrate on whose shadow is this. Just concentrate on to whom the shadow is on right or left. To whom the shadow is on the right or left. So concentrate that point and you can answer the questions easy. Next example. Shadows based problems. Read the question first. One morning, immediate after sunrise, okay, Jyoti and Jeevana were sat in a park such that their backs towards each other. In the previous case, we have seen the persons facing each other, but here the two persons are nearby only, but their backs towards each other. So in the previous case, this is the case. The two persons are facing each other, but here the two persons are here only. Their backs towards each other means this person is facing in this direction and that person is facing in that direction. Okay. So in the previous question only, I have one more doubt. See, sir, sun we have considered here, shadow we have considered here, and why we have to take the persons in this way only? Why don't we take the persons in this way? Why don't we use this pair? Why we have to use this pair only? Yeah, see that one. For this person facing this direction, facing this direction, because in the question he has mentioned the shadow is on the right or left. For this person, the shadow is on the right. For this person, the shadow is on the left. Suppose if we use the front and back, then use this set of person positions. Use this set of person positions. Okay. So here he has given back side. We'll use this one. This only. Let us draw the diagram first, or otherwise directly we can get the answer. See here, directly we'll get the answer first. Later we'll see the concept. In the morning, shadow backside of Jeevana only. Jeevana falling, shadow of Jeevana falling on her backside. Morning, shadow back of Jeevana. Morning, shadow back of Jeevana. I will go to that slide. Morning, shadow back of Jeevana. So this is the morning. Back. Shadow is on the back means Jeevana is facing east. Now what is our question? In which direction Jyoti is facing? Jeevana is facing east means automatically Jyoti will be facing west. That's all. That is the answer. Oh, let's see with the diagram and concept. In the morning, sun is on the sorry. Yes, in the morning, sun is on the east direction. Persons are here, and their shadow is here. The two persons are facing opposite directions. Means so their backs towards each other. Backs are towards each other. In this case, for this person, shadow is in front, and for this person, shadow is on the back. In the question, Jeevana shadow is falling on her backside. Suppose if we consider this as Jeevana shadow, this Jeevana shadow is falling on the back of Jeevana only. So this person will be Jeevana. And automatically Jyoti is facing, sorry, this will be Jyoti. Now tell me in which direction Jyoti is facing. So Jyoti is facing west. Jyoti is facing west. That is the answer. And without this process also, we have seen the answer directly.